Here's an exponent trap that 99% of people fall into. Which one is larger? 20 to the power of 25 or 25 to the power of 20? These two numbers look almost symmetric. Same 20 and 25, just swapped. If either the base or the power were the same, this would be easy. But now, it feels tricky. Before doing anything, don't reach for a calculator. Let's pause for a minute. Notice something interesting. 20 and 25 both have 5 as a factor. So a very natural idea is this. Can we rewrite both numbers using base 5? If we could express everything in the power of 5, comparing them should become straightforward. Let's start with 20 to the power of 25. The power of 25 means we multiply 20 25 times. And 20 is just 4 copies of 5. So that is 25 times 4 equals 100 copies of 5. 20 to the power of 25 equals to 5 to the power of 100. Easy. Now, what about 25 to the power of 20? Same idea. We multiply 25 20 times. And each 25 is 5 copies of 5. So that is 20 times 5 equals 100 copies of 5. So this one is also 5 to the power of 100. Since both number equals 5 to the power of 100, they must be equal. Or are they? Everything we just did feels perfectly logical, but it cannot be true. Here's a quick proof from the factors. Let's look at 20 to the power of 25. Since 20 has a factor of 4, this number must contain 4 as a factor. Now look at 25 to the power of 20. 25 has a factor of 5, but it does not have factor of 4. Raising it to any power will never introduce a factor of 4. Two equal numbers must have exactly the same prime factors. These two don't. So something must have been wrong. They are actually not equal. So where did we mess up? Let's work backwards. We ended up with 5 to the power of 100, meaning 5 multiplied 100 times. The 100 came from 4 times 25. The 25 makes sense. We multiplied 20 25 times, but what about 4? The 4 comes from writing 20 as 4 copies of 5. And here's the critical mistake. To create an exponent, we must multiply, not add. If 20 were 5 to the power of 4, then we could multiply the powers, but 20 is actually 5 plus 5 plus 5 plus 5, not 5 multiplied 4 times. The mistake we made is that we treated addition as if it is multiplication. That is the trap. Let's fix this correctly. Take 25 to the power of 20. 25 is 5 copies of 5 added, but 2 5 multiplied. So it is not 5 to the power of 5 times 20, but actually 5 to the power of 2 times 20, 5 to the power of 40. So what is the right way? We can rewrite 20 to the power of 25 as 20 to the power of 5 times 5, and 25 to the power of 20 as 25 to the power of 4 times 5. Since they both have 5 in the powers, we can rewrite these two numbers with brackets. So now we don't need to compare the original two big numbers, we only need to compare the new bases in the bracket. Now the numbers are much smaller. Now, compare 20 to the power of 5 and 25 to the power of 4. 20 to the power of 5 is basically 2 times 10 to the power of 5. Working out the power of 5 for 2 and 10 individually, we can easily get the answer should be 3.2 million. And for 25 to the power of 4, since we know 25 squared is 625, so the answer is basically 625 squared. Then estimate 625 is obviously smaller than 1000, so the result should be smaller than 1000 squared, which is 1 million. Now let's compare 3.2 million to 1 million. The answer is very obvious. 3.2 million is larger than 1 million. In other words, 20 to the power of 5 is larger than 25 to the power of 4. That means 20 to the power of 25 is larger than 25 to the power of 20. This exponent trap is extremely common, especially for students just learning indices. They confuse adding copies with multiplying copies. Adding 4 5s give us 4 times 5. Multiply 4 5s give us 5 to the power of 4. Same number 4, but they mean completely different operation. One adding 4 times, the other multiply 4 times. So, our final tip, whenever you work with exponents, ask yourself, am I multiplying here or am I adding? If you confuse these two, you've already fallen into the trap. Now, your turn. Which one is larger? 28 to the power of 35 or 35 to the power of 28?